So, we have talked about the different states of matter and the molecules, really. Thank you. And what we're doing today, and I've told you we were going to do this, we are going to build the different molecules, or the different states of matter, using marshmallows and toothpicks. So we're going to build them, which is why I have almost emptied this bag here. And you're going to start with, well, ew, marshmallow guts. We're going to start with a solid. So what does a solid look like? The molecules inside the solid.
Stuck together.
Why are they stuck together? How do you know that they're stuck together? Let me rephrase.
Because it's frozen. And it's in the board. And I don't remember that.
Okay, can anyone else help?
You say what?
Solids. The inside of a solid.
They stay the shape.
They stay the same. They don't have no room to move.
Exactly. So solids, they stay this. Like if you were to throw a block or a bunch of blocks up in the air,
They'll fall in and break our heads.
it's going to stay the same. Well, what about a liquid?
It's gonna go everywhere.
It's gonna speed.
So it'll spill. It'll go everywhere. And what about air?
They take you away.
Air will take you away.
It was windy last time I was like this and the air was like. I would do it
I like the sound of it.
So what does air do?
Yeah.
Would it help you if you visualized what the air molecule looks like?
Yes.
You can't even see it.
Well, if you know,
They space down. Because it's
How-
nothing.
how do you know?
Because
This is evaporate, no.
because they
Okay,
space-
because it's everywhere. Exactly. That means what?
They
They
spread.
spread.
They're spread out. What else do you know about the molecules in that state of matter?
They got so much space.
It has space to move.
They have space to move. Now, if you compare an air, the state, not air, a gas, which is what air
That's a
is.
fart.
Yeah. Okay. Oh, let me regain my composure. Blake brought up something that was interesting. He said it was like a fart. Well, that's what it is. It's a gas.
It's
And when you
red.
fart, what do the people in the classroom do?
Die.
Ew.
Laugh.
They laugh, but what do they do?
They smell it.
Do they want to smell
They
it?
breathe it in.
No.
No, Johnny.
They inhale it.
Johnny
What do
just
they
farted.
want? What's your first reaction when someone around you farts?
Really?
To hold my nose.
Seriously? You could have said
Stink.
excuse me. Like,
He was like,
What are you wanting to do? Do you want to sit there and
Move.
smell it?
fan it away.
Fan it away? You want to what?
Move.
You want to move. You want to get away. Okay? So think of that when you're thinking about gases and the molecules within a gas. You want to spread, get away from it. Okay? Liquid, think about swimming, being in a pool. You can move around. It's not as free as air is. Like if you were skydiving or something, you could float wherever. But if you were in a pool, you're all nice and chilled and sunburned. Yeah. And the solid, can you move if you're frozen? Can anything that's frozen inside an ice cube move?
Fishes do.
No.
they don't
Fishes don't,
unless you know, and it becomes
Fishes
a
don't feel pain.
because the entire lake hasn't frozen. That's why they can survive.
Are you
at the bottom.
recording right?
Did you know fish can't feel
Okay.
pain?
So what we're doing, we are building these molecules, and we're talking about what happens when a liquid becomes a gas and liquid becomes a solid. What do those molecules look like?
Like
Can we build?
green.
Yes. Feel free. Build away. Go ahead and start with
Nika,
what?
she start eating.
I did. That's okay. Start with the solid.
Miss V, what is
Dorian, go ahead and grab one. What's the solid? Remember, what does the solid look like?
It's, oh.
Yeah, what if you just told me that the solid can't move, so what does that mean as far as the marshmallows go?
No.
They stuck.
They're
That's
stuck
amazing.
together. Now, do you have to put 5 marshmallows on a toothpick?
Cray cray.
No, you don't have to.
Dang.
Trust me, I got plenty. We're fine.
Miss V, why are you sticking them together like?
Well,
I didn't know I was gonna be able to eat them.
You trying to make a cube? Square.
well, I'm just making an example of a molecule. Demorion, do you have some at your seat? I put some over there.
I'm about to smash, man.
Okay. Now, are they gonna look perfect?
No, maybe.
No. Because this is just a very bad representation, but still fun, and you're gonna get sticky, and you're gonna end up having to wash your hands.
Be happy, y'all smile.
Now, what about if I were to make the liquid? So you're making solids right now. So as you're making the solid, think about what a liquid would look like.
A little spread out.
A little spread out? And remember, there's even more. That's a good example of a solid.
Got that solid messed up.
So what about the liquid?
Liquid?
Mm-hmm. Liquid.
I think I have no example of that.
You don't have an example of a liquid? What would a
Oh.
liquid look like?
Like this.
So, let me hold up Nika's. What do you notice about hers?
It's all together, Miss B.
It's all together. It's solid. Can these molecules move?
No, it don't got enough room.
Yes,
No, they don't have enough room. What's the difference between the solid and the liquid?
You can't move around with the liquid.
You can move around. Can you move around as freely as if you were a gas?
No.
No, exactly. So here's mine and here's hers.
That
I didn't want to stick as many. This could be what?
liquid.
Yeah, this one could be the liquid. Now, when we make the gas, what are we gonna do?
Oh,
But like, you gonna be basic.
you're gonna be looking like this.
It's gonna be looking like what?
That's gonna be kind of hard. Like this.
Funny. Could be, yeah. It could be
Oh, hold
just the
up.
two.
I'm not eating your
A
marshmallows.
liquid or a gas like
Like
a
this.
fart.
Gas, dude.
Well, gas like a fart, and remember, gas. When you think of the molecules, think of them as very well spaced, because if somebody farts around you, then you want to.
Die.
No, you want to run away.
Wow. Jocelyn, don't be talking about me.
Oh, I
'cause
wanna
you
make
been
a
smelling.
gingerbread
Johnny,
house.
I didn't say nothing.
Ladies. Really?
What order would it go in? Like that, Millie?
They can go in any order that you want them to. Now, just because of the way that the marshmallows and the toothpicks are working, I've had to put.
Oh, I'm gonna make a big house and I'll put Millie.
You are making molecules, not houses.
Yeah, you don't have to make house.
Look, Miss B, I made a.
Miss B, what are we? Oh,
Because he's over there eating.
Right.
Smash it on them too.
What?
never mind.
Okay. You answered your own question?
Yeah.
Okay. I
Oh,
sometimes like it when that happens.
oh.
A little more
Save
building.
mine.
A little more building and less eating, please.
See, I built 3 already.
Are they all the same?
No?
Ah, I'm sicking.
I'm building the liquor right now.
You good know what?
Well, that's fine because they're yours.
Liquid.
Oh, I thought you were.
See, Era, what are you doing?
She'll get some.
Pass me that.
Okay, Sierra, can you give me a marshmallow?
You want some marshmallows here? Janae keep using my marshmallows.
I have more bags. We're good. Trust me. See, notice with my, I'm building it up.
What are you trying to say?
I'm making a molecule.
I'm making a tea.
It doesn't have to be just 4 toothpicks stuck together. We can make it 3D.
I'm making a sheet.
Trust me, we've got enough marshmallows that we can do that. But the whole point of this is for you to see,
How many marshmallows did you
no.
Mr. Floyd, please call the office on 402. Mr.
The
Floyd.
point of this is for you to visualize and create an example of those different types of molecules and what they look like. What the molecules in a solid state look like versus what the molecules in a gas state look like. When a gas becomes a what? A liquid.
It could become a solid too, like Jello.
Yes, but when a gas becomes a liquid, what do the molecules do?
spread out?
No, it's already a gas. Remember, you're spread out.
Transform. Like a
No, when a
transformer?
gas becomes a liquid, what happens? What do the molecules do?
When the gas becomes a liquid, the molecules spread out.
When a gas becomes a liquid,
They get more together.
which one is it? They spread out or they get more together? You do too know. What happens?
They, maybe I can find it. I know.
Well, think about it in your head. The gas state, are the molecules spread apart or are they really close together?
Spread in the gas.
In the gas, they're spread apart. In a solid, they're what?
They're stuck together.
They're stuck together. And then the liquid, they are
A little spread out. But then
a little spread out. So if we're going from a gas, which is sort of like something like this, and we want to go to a liquid, which is like this, what is happening to the molecules?
Coming close
Evapor.
together.
What's causing them to get closer together?
Probably.
Gravity.
No, not gravity. Think about what happens to a liquid when it becomes a solid. What's causing it?
Heat.
What's causing it to go from this to this? I'm pushing too hard on my marshmallows. I'm doing all kinds of weird things. What am I doing to this? We'll start here with this one. I still want to get back to going from a gas to a liquid, but I think it'd be easier if we start here with our liquid, DeMorian, and move to our gas, or to our solid. What's happening?
They're getting close.
What's causing them to get closer?
Hey.
Heat's causing them to get
Air.
close? Air is causing them to get close.
Because
This is a liquid, and this is a solid. What's an example of a solid?
ice.
Okay, what's an example of a liquid?
Oh, freezing it.
Yeah, water. How would water become ice?
Freeze.
Freezing it. Now, if this were ice, and this is water, what would you have to do to the ice to get water?
Leave it out.
Leave it out. Melt it. So,
I've been like,
right. So, taking just that, if I go from a gas to a liquid, what am I doing to it? Is it getting,
I'm transforming.
Freeze it. From a gas to a liquid.
Well, I'm not freezing it because this would be the frozen state. But it's what? I can see it in your face. I know that you know it. Okay? So, using the same principles. Water, ice. For water to become ice, it has to what? It has to water.
Freeze.
It has to freeze. What does freeze mean?
Get cold.
Get cold. So to go to air, or from a gas to a liquid, what does it need to do? It's gotta get cold. It's gotta get hot. Nika,
Look at my pyramid.
You should have caught that.
should have opened your mouth.
Oh, look.
So from a gas to go to a liquid, it has to get cold. And then from a liquid to a solid, it has to freeze. Now what about going the other way? For a solid to become a liquid, gentlemen, it has to melt, which means what happens?
Hey,
Wait, a
so
solid
you can
to
tell.
A solid to a gas, I'm getting ahead of myself. A solid to a liquid, Blake, it has to what?
It gotta melt.
Melt. So what causes something to melt?
Heat.
Heat. So we are applying heat. And so to go from a liquid to a gas,
Oh.
from a liquid to a gas, it what?
Liquid to it.
Wait,
Heat.
to gas.
Liquid to a gas. Remember, it's the opposite. Liquid to a gas, look at the molecules.
Steam.
Steam.
Oh, really, John?
How do you get it to steam? How do you get it to
We
steam?
was watching. Like
What do you do to it? What do you do to water to make it steam?
You heat it up.
Boil.
There you go. So,
think of that video we watched.
can what?
Using food, for example.
Well, not just food, but
This is a fun way to
We
do
watched the
it.
video, I know.
there you go.